Hi friends, my name is V. Suresh Reddy. Now I am starting the Computer Network Lab 6th IP. IP means Internet Protocol. It is a IP protocol which is focusing on the IP diagram, which is the IP datagram sent here receive on the exception of traces. Now I am doing the first experiment capturing packets from a execution of trace route. In the first experiment, in order to generate a trace of IP datagram of this lab to build the traces the IT labs. In this we will run the trace routes of the set diagrams of the various lines. Windows C these the GAIAs of us.edu. This is the ping platter free diagram, which is the graph. This is the Latin diagrams, maximum, minimum, and the currents. These we can show here. These are the IP address and the counts, and these are the like the splitting of the graphs which we have shown here. Now we can see the here we can start up the Wireshark and begin the packets capturing and starts on the Wireshark packets capture opening the screen, and we all these like this we can do the capturing of these packets. All things we can do here by the Wireshark tracing by the using of Unix and Mac platform. For these, in these we are downloading the zip file, and see here the zip file for this zip file I want to capture here. Now I want to capturing these packets. After capturing these packets, this is the capturing after the packet. Now I am opening in the Wireshark. See, this is the after capturing of these packets. These are the packets are capturing here. See, after downloading these file, these are the capturing packets. See, once after these internet control message, these all the files are they having here. These are the pinkplotter.coms, and these are the Wiresharks which we have done. After the second, a look at the capture trace is the we are doing the in a packet. See, we have seen the ICMP echo request message we have seen in the Wireshark. Let us see here. These called the 0.06 file. After the print, these are the packets we have selected packets. Now we can see here the selected packet only. Now we can reach. Now we can do the request of the selecting the first ICMP echo request message sent by your computer. This is the packet we have taken the screen to print now. That is the packet we have seen here. Now opening the Wireshark, we can see here these are the 1.1 and the HTTP messages and all things we are doing here. See, this is the processing of these, analysis of ICMP questions, selecting of ICMPs. These are the printouts of the layouts. See these the IP address for the version of 92.168.1.102. This is the IP address. See, this is the same IP address which we have shown in the POC. This is the internet controls and the internet protocol. See, after this we are typing a ICMP message. When typing this ICMP message, here the request of ping, which is the packets we have seen here. After these, now we can see all these lives by seeing here. See, these are the helps and the source of the same screenshot we have seen here. Now these we can see in the Wireshark same as like this. What is the IP address of your computer, and this we can see here same IP address 10.26.192.168.102, and these values with the packets IP data headers packets. See, upper layer. See, now we can see the upper layer value. This is the checksum status of the upper layer value is, we can see here, show the upper layer packet value. Just a minute. See these just show me. I will show just the value ICMP. Just I can see CMP. This is the ICMP values. Now we can see here ICMP values. These are the protocol which within the ICMP how many bytes are there in the IP address that we can see. We can see these are the 20 bytes that we have shown in the 20 bytes and the paragraph of 64 bytes because we used the 84 bytes and the header length of the 20 bytes. So the paragraph is the 64 bytes. Here we can show, see in the same that the same control same internet protocol to the timeline. We can see the total length is the 84 and the header length is the 20 byte and the total length is 84. Here we can see the total length of this. Now okay, now we are seeing this. Now we can, how we can determine the bytes and the IP address has the datagram. Yes, if the IP address, the platform is not set in the not fragmented, so it is not set in the set of the fragment. Now we can go to the time to leave of the flag number is 0.0 and the fragment offset is 0, so it is not set in the fragment of this one. So now I can solve the second question with another question, which field of the IP address is always changed from the datagram. We can see which field state the constants, see TLD filer and header files, and we can show that in the here header identification, time of the application. The next question we can see here, which will stay the constant. Now which what are the details of the select packets, headers, windows in the listening of the capturing packets. In this describing the pattern to see in the values of the identification field. Now we can see the field constant in the TLD and the header checksums. These we can see here. After these here 13008, this we can, when we click on this we can see the internet control message protocol, which is the ICMP flags which are seeing here. See here, this is increasing by 1 by capturing the 98, 98, 70. These are capturing by 1 by 1. These are happening here. After these 1093, see here the capturing of packets are done. Now we can see the do these by the same video that we have seen here. That is the which is the data find the first ICMP echo reach. Also we can see here the first part of this value is the increased by 1. After this, now we can see here the identification time to leave is 1, so the protocol ICMP also 1, so the time taken is also increased by 1, so we can do it. The time to leave is decreased to 1. The identification, this identification TLC is unchanged. Just we can see it also. First thing, having the 2 fragment values, that we can see the printing out of the layer fragment IP datagram, which the IP address indicates the datagram before the fragmented. These also we can see here in the Vaishak. Now we can see the identification number, that we can see here the checksum values, and these, see we can see the just now I am doing these required capturing packets. Now just a second, I am seeing these values. It's siblings. Just wait. It's having more packets are capturing here. We can see here the requests and the exits are happening here. The packets, yes, I got these see the packets of these 2000 and these we are seeing here. These identifier layer we can see here the 2000 showed case configuration we can see here, and the print out the second fragment of the fragmentation IP address. What information of that IP address indicates that this is not the first fragment. We can see here this is the ASCII code for the which is the belonged to the on the address, and the third we can see the what is the change of IP address IP header between them. Last we can see in the POC total length, flag, more fragment, and the flag offset. These are the we can see here, and also the which are the fragments that are created here means the what field changed in the IP address between them are the fragments datagrams and the IP header among the fragment which is identification and message internet control message protocol of the checksum of the bits we can do here. These are the wicked happening here, the uniform and the checksum beforms message protocols. These are we can message protocol type of echo ping request and request exits. These all are we can see here total what field changed an IP address header among them, total length, flags, and these have done these flags, more fragments, and these are done. Now we have completed with our lab. Thank you.